Alrighty, so in the figure shown below, the length of AC, which is what part of the line? The whole thing, right? AC is 45 meters long. Okay, so I'm going to do this number, and that's 45 meters. Okay, what is the length in meters of BC? So ultimately, are we finding the length of X? Is X only the measurement of BC? No, what's the measurement of BC? 2x plus 5. Okay, so what do you think that we should do? Add these two equations together. Why? So it would give us the whole line, right? This piece plus this piece equals 45 meters. So I'm going to take 3x plus 2x plus 5 is equal to 45 meters. Okay, how many of you got this far? Okay, hands down. All right, what should I do next? Alan, what do you think I should do next? Looking at this equation, divide 45 by 2. Does it say that AB and BC are equal lengths? No, so can we divide it by 2? No, if it doesn't say that they are equal parts, even if it looks like equal parts, can we do that? No, you cannot assume anything. You can only assume what they tell you. Okay? Wilson, I need you to put your ID on your neck, please. Thank you, sir. All right, what should I do with this equation? Where's your ID? Okay. What should I do next? Compare? Combine like terms, right? Okay, so perfect. 3x plus 2x is how many x's? 5x. I'm still left with my plus 5, which is equal to 45. Very good. Now what? Subtract 5. Y'all agree? Subtract 5 only from 45? From both sides, from the positive 5 and the 45. Oops, that's not what I wanted. So we end up with 5x is equal to 40. Very good. And now what? Why do I divide by 5? To get x by itself, because x is being multiplied by 5. That's how many x's there are. So then x is equal to 8. Okay, but did we say we were solving for x? No, we said we were solving for b to c, which is 2x plus 5. So what do? I need to put in the value of 8 wherever I see an x. Remember, variables are just what? Placeholders. So the placeholder is there right now until we have an actual value for x. Now the placeholder doesn't need to be there anymore, right? So now I replace it with 8, because originally it was 2x plus 5, right? Y'all with me? Yeah? Okay, so 2 times 8 is 16, and then 16 plus 5 is 21, which is answer A. Okay? So linear means what? Okay, when we graph something, it makes a straight line. So graphing, okay, we can do this. There we go. Okay, linear makes a straight line when we graph, right? So then non-linear would be what? Not a straight line. What are some examples of non-linear graphs that we've seen? Circle, a curve, the one on Kahoot, okay, a squiggly one, right? Not a straight line. Yes, sir?
Would non-linear, could it be like a line that's not in the exact, you know that one where we thought it was not a function because we thought it would change it?
What? What's increasing? What do we say increasing was? We use that fancy definition. It's going up. So what has to increase? The x values increase, then what happens? The y values increase. Good job. I didn't know if we were going to remember that. I'm so proud of y'all. Okay, as x increases, y increases, right? So then what's decreasing? Nope, as x what?
As x
Increases, right? X is always increasing, right? Because we read it from left to right. Okay, so as x increases, the y's do what? Decrease. There you go. All right, so there is... Okay, so let's go ahead and look over the answers, okay? Raise your hand if you want to go over step by step the graph. Okay, I want you to check your graphs right now. Okay, A and B should be linear increasing. E and F are linear decreasing. E and F. Ooh, good point. It does change. It's not one continuous line, so I need to change that one. Okay, so change F. Okay, so non-linear decreasing. F is non-linear decreasing. Good. Thank you. I will fix that. Okay. Okay. D, I, J, K, and C are all non-linear increasing, right? Does that make sense? Any questions about those? About the non-linear increasing graph? Okay, non-linear decreasing graph. I know you can't really see that one. Let me try and move it. Let me try and move this. 5, so plus 5. And then from 9 to 16, plus 7. And then from 16 to 24, plus 8. So is it increasing the same each time? Because what did you notice about the linear increasing and linear decreasing? Okay, did anybody else notice that, what Grant noticed, that every single time it increases by the same amount or decreases by the same amount? Yes? I have 3 yeses, 4 yeses. Okay, so then for this one, with the babies, we can see that if it's growing by 5 the first time, then 7 the second time, and 8 the third time, based on what we've observed in the red and green column, this is not the same, correct? Okay, so then let's look at the nonlinear decreasing. Which table do you want to look at here? The life expectancy. Okay, so the ages are increasing by how many the first time? 5. Plus what? Okay, 1,000 years. So plus 5 the first time, then how much the second time? Plus 5. So far, is it looking linear? Yes, and then the second time? Plus 10. Oh, that's not the same. Okay, let's decrease the number of survivors. Okay, 1,000 to 979 is a difference of what? 21 minus 21. And then 979 to 978 is a difference of 1. So is this linear? No, absolutely not. But is it increasing or decreasing? Decreasing. Okay? Any other questions?